Most people who start doing load testing think of it as a single activity. You run a load test, you see if the system handles it, you move on. That mental model is the reason so many teams have load tests that pass and production incidents that happen anyway. Load testing is not one thing. It is a family of related techniques, each designed to answer a specific question about a specific category of failure. The three most important types are stress testing, spike testing, and soak testing. Each one probes a different failure mode that the other two will completely miss. A system can pass your stress test with flying colors and still go down during a flash sale spike because spike tests expose a completely different class of problems. A system can handle both stress and spike tests perfectly and still degrade gradually over 12 hours because soak tests look for failure modes that accumulate over time rather than appearing immediately under high load. In this episode we are going to cover all three test types in depth, what question each one is trying to answer, how to design it properly, what the results look like when you find a real problem, and when your team should be running each type as part of a complete performance testing strategy. Stress testing is about finding your system's breaking point. You start at a low load and gradually increase virtual users over time, watching what happens as the system gets closer and closer to its capacity limit. At some point, something breaks. Response times spike above acceptable thresholds. Error rates jump from 0 to 5 or 10%. Maybe the application process crashes entirely. The goal of a stress test is not to avoid breaking the system, it is to find exactly where it breaks and understand what the failure looks like. Does it degrade gracefully, serving slower responses but continuing to function? Does it fail fast with clear error messages? Does it crash silently and take several minutes to recover? Does it recover cleanly once load drops, or does it stay degraded? All of these are important questions. In case 6, you implement a stress test using the stages option in your executor configuration. Define a series of stages, ramp from 0 to 50 users over 2 minutes, hold at 50 for 5 minutes, ramp to 100, hold, ramp to 200, hold, and so on, pushing well beyond your expected peak traffic until something breaks. The output will show you exactly where the system started struggling. Spike testing is different from stress testing in a critical way. Instead of a gradual ramp, you simulate a sudden, instantaneous surge in traffic. Think about what causes traffic spikes in the real world. A celebrity tweets about your product. A news article goes viral. A marketing email goes out to 1 million subscribers simultaneously. A flash sale starts at exactly noon. In all of these cases, you go from normal traffic to many times normal traffic in seconds, not minutes. The question a spike test answers is, how does your system respond to sudden demand that it had no time to prepare for? Does autoscaling kick in quickly enough to handle it? Or does the system fall over before new instances come online? Does your database connection pool exhaust in the first few seconds of the spike? Does your content delivery network absorb the static asset requests, or does everything hit your origin servers? In case 6, you design a spike test with a very aggressive ramp stage. Go from 0 to your spike level, maybe 10 times normal load, in 10 to 30 seconds. Hold at that level for a few minutes, then ramp back down and observe recovery behavior. Spike tests are especially important for consumer products with any kind of event-driven or marketing-driven traffic. Soak testing is the third type, and it is the one most teams never run, which is exactly why it is so valuable. A soak test runs your system at normal or moderately elevated load for a sustained period. Not 5 minutes. Not 30 minutes. Hours. Sometimes days. The bugs a soak test finds are the ones that do not exist at low iteration counts. They accumulate over time. A memory leak that adds 10 megabytes per hour takes 6 hours to become noticeable and 48 hours to crash the process. A database connection that is not properly returned to the pool on certain code paths, maybe a code path that only runs occasionally, will gradually exhaust the connection pool over hours of sustained traffic. Log files that are not rotated will eventually fill the disk. Third-party API tokens that expire after 8 hours will cause authentication failures if your code does not handle token refresh correctly. File handles that are not closed properly will hit operating system limits after enough requests. None of these bugs show up in a 5-minute test. Every single one of them has caused production outages at real companies. A weekly soak test run against your staging environment overnight would have caught all of them. Now let me give you a practical guide for when to actually run each type. Stress tests, run one before any major capacity planning decision. If you are deciding whether you need to scale up your infrastructure, you need to know your current breaking point first. Run one before a major launch or high-traffic event. Run one anytime you have made a significant change to your infrastructure or architecture. Spike tests. Run one if your product has any event-driven traffic patterns, marketing campaigns, product announcements, scheduled sales, anything where you know in advance that traffic will jump suddenly. Spike tests are especially important if you are running any kind of autoscaling, because you want to verify that autoscaling actually works fast enough to protect you. Soak tests. These are the most important to run on a schedule rather than just before releases. Run a soak test as part of your release checklist for major versions. Schedule one to run nightly or weekly against your staging environment. Run one anytime you have changed how the application manages state, connections, or memory. The nightly soak test that runs while no one is in the office and alerts on call if the error rate climbs is one of the most effective ways to catch production-bound bugs before they ship. Stress, spike, soak. 3 tests. 3 fundamentally different failure modes that you cannot discover with the same test design. If you only ever run one type of load test, which is the case for most teams that do any load testing at all, you are systematically blind to 2/3 of the failure modes that production traffic can expose. The good news is that the implementation effort for all 3 types is not that different. Once you have your K6 setup working, adapting your script for a stress test, a spike test, or a soak test is mostly a matter of changing the stage's configuration and adjusting your thresholds. The conceptual work of knowing what question you are trying to answer and what success or failure looks like is actually the harder part, and you now have that. In the next episode, we are going to take all of this capability and bring it directly into your development workflow by integrating load testing into CI/CD. We will build a GitHub Actions pipeline that runs a load test automatically on every pull request and fails the build if performance degrades, the same way your unit tests fail the build if correctness degrades. Subscribe and I will see you there. Let me give you a practical starting point for implementing all 3 test types without getting overwhelmed by doing everything at once. The approach I recommend for teams new to load testing is to introduce these test types incrementally over 3 to 4 sprints. In the first sprint, set up your basic load test infrastructure, K6 installed, a smoke test script written, running manually. In the second sprint, convert your smoke test into a proper stress test with ramping stages and thresholds, and run it once against your most critical endpoint. In the third sprint, write the spike test for your highest risk traffic pattern, whatever event or scenario is most likely to cause a sudden traffic surge for your specific product. In the fourth sprint, set up the soak test as a scheduled nightly run against staging. By the end of 4 sprints, you have all 3 types running without having taken on everything at once. Each sprint delivers standalone value. The stress test finding in sprint 2 might already justify the entire effort. This incremental approach also gives your team time to develop the muscle memory for interpreting results before you are looking at data from 3 different test types simultaneously.